All right, gentle people, let's go ahead and tackle this question out. So let's take a look at the information given in this problem. And so what this problem gives us is it gives us the mass of our products, and it also gives us the mass of our reactants. Now, if we want to relate the mass of our products to our mass of our reactants, we have to go through a chemical equation. So what we should do is write down our chemical equation and note that things in our chemical equation are related to each other through moles. So we need to change everything from grams, or our mass, to moles of reactants and products. So let's go ahead and write down a balanced chemical equation. So I'm going to go ahead and read the problem out, and it says that I have scandium metal, and I'm reacting it with hydrochloric acid to give scandium chloride, but I don't know what the ratio of chloride to scandium is. A byproduct of this reaction is hydrogen gas. Now that I've written down the equation, I need to balance it. We see that we have one scandium and one scandium on either side. Next, let's do HCl and scandium chloride. Now, I don't know what this number here stands for. So what I can do is I can go ahead and say X right in front of that HCl. Because if I put an X there, it gives me the appropriate amount of chlorides on either side. I have X chlorides on my reactant side. I have X chlorides on my product side. So the last thing we have to balance out is our hydrogens. Now, what you will notice is hydrochloric acid has only one hydrogen, hydrogen gas has two hydrogens, and so if I were to pick a number, let's say X was 6, well then I would put a 3 in front of my H2. If X was 8, I would put a 4 in front of my H2, because that will balance out the number of hydrogens on either side. And so what I can do is I can put X over 2 as my coefficient. Now what you'll see is I have X hydrogens on the reactant side and X hydrogens on the product side. So there are equal amount of hydrogens on either side. So now I have a balanced equation. So let's do the next thing we mentioned in this problem, and that's calculate our moles. So the problem gives us 2.25 grams of scandium metal. To change into moles, I'm going to look on my periodic table and get the molar mass of the scandium metal. And then I'm going to divide by my molar mass, and I'm going to get 0.0500 moles of scandium. I'm going to do the same thing for my hydrogen. The problem tells us I have 0.1502 grams of H2. I look on my periodic table. The molar mass of a single hydrogen is 1.008. There's two of them, and that's going to be grams per mole of H2. I do this division, and I get 0.0745 moles of H2. Now that I've got the moles of byproducts and reactants, I can relate these moles together using the chemical equation and stoichiometry. So 0.0500 moles of scandium, I'm going to go ahead and times that by the mole ratio. The mole ratio says that to make X over 2 moles of H2, I'm going to need 1 mole of scandium. So again, I'm looking at these coefficients in front of my chemicals in my chemical equation. Now this is going to equal 0.0745 moles of H2. So I'm going to go ahead and solve for X. In this case, X is going to equal 2.98. And we know that subscripts have to be whole numbers, so I'm going to round that to 3. So to answer this question, we know X is 3, so we go ahead and identify what the formula is for our scandium chloride, and that's going to be SCCl3.